Okay, so welcome to the first lesson. Hopefully it's going to go all right. So we're going to start off with naming of alkanes, revision from last year. So you count the number of carbons in the longest chain. I'll give an example soon. So it's 1, 2, 3, and you need to know all the way up to 10. Once you've worked out how many carbons are in the longest chain, then you know what prefix to use. So as a reminder from last year, it's meth for 1 carbon, eth for 2, 3 carbons is prop, 4 is bute, 5 is pent, then it goes hex, hept, oct, non, dec. So an example is something like this. Okay, as far as reactions go, there is several that you need to know about, including some new ones for this year. So the first one we're going to look at is oxidation. So you remember from redox, hopefully, that oxidation, if something is oxidized, so we're going to oxidize the alcohol, it will gain oxygen, lose electrons, change oxidation number, or the one that we don't normally talk about, it can also lose hydrogen. So that's the easiest way to think about it when we're talking about alcohol. So I'm going to use this model to illustrate it, but don't stress too much. You don't actually need to know any of the side products. You just need to know the reaction itself. So you can oxidize an alcohol, a primary alcohol, so that's why I'm using that one there. So if we've got you can see that this is a primary alcohol because this carbon that the alcohol is joined to one other carbon, so that's a primary. When we oxidize it, we need to do it with heat, which triangle is the shorthand for, and we can do it with either acidified potassium dichromate or acidified permanganate. So your color change that you'll see with this will be purple to colorless, and this one will be orange, and it will change to green. Okay, so those are the two color changes. Now last year we taught that oxidation of a primary alcohol went straight to a carboxylic acid. As with everything, that's not quite true. What actually happens is it's actually a two-step process. So first off, what happens is we lose the hydrogen off the OH, and we lose another hydrogen off the carbon, and we end up with the a double bonded oxygen on the first carbon there. It looks like this, and this is what we call an aldehyde. Now I'm going to talk about aldehydes a little bit later. You just need to know that that is the middle step of this reaction. So it actually looks like this. So an aldehyde is a carbon with a double bonded O and an H on the end of a chain. Now we're still only talking about primary alcohols, what happens when they react them. So that then goes through a second step. If we leave it in there to continue reacting, we're using the same reagents as we did before because they're still in the solution, and we end up with the carboxylic acid as we said in the past. So in that case, we just end up adding, is the second definition for oxidation, or one of the ones that I didn't talk about up here, but another one is we could also add an oxygen. So we are going to add an oxygen to this. So we add an oxygen over here. So we end up with our carboxylic acid, which is a C double bonded O and a C with an OH on it. So here is our carbon. Here is the double bonded O, which is the double bonded O from the aldehyde, and then we get the acid part which is the OH. So this is your acid, your carboxylic acid. Okay, so now we're going to look at the oxidation of a secondary alcohol, R meaning rest of chain or anything else, it doesn't really matter, and OH being alcohol. So this is shorthand for symbolizing alcohol, but if I just make that a little bit tidier, R-OH. So when you see that, that means it is an alcohol. Now, if you look here, we have butane 2-ol, 4 carbons long, alcohol on the second carbon. So if I just draw that, okay, so that's what I have here. When we oxidize it, we still use the same reagents. So we could use acidified permanganate, which of course will go colorless, so no color, or acidified dichromate, which will go green, so you still get the same color changes as before. Again, you don't need to talk about this, what the other products are in this. You only need to know about the side products or what the alcohol reacts to. Now, as before, oxidation is losing of hydrogen. So we lose this hydrogen here, and then we lose the hydrogen on the carbon, and we get a new bond forming here. And so this is your new molecule. This is called a ketone, and this would be butane 2-ion. And as I said before, with the aldehyde, I'll talk about them a little bit later. So when we're drawing our product, so you see I've got CH3, here's my CH2, here's my carbon, and here's my CH3, and then I can just put on my double bonded O in the middle of the chain, which is what I have here. So this is my ketone. Okay, now you also notice that there is no actual other bonds that are free on here. You can't break a bond between two carbon atoms. It's just too hard to do. So this won't react any further. There's nothing else that you can do with a ketone because there's nothing else free. Whereas with the primary alcohol, when we got it here, we had a carbon hydrogen bond, which isn't as strong, which is why we could add the extra oxygen into it to get the carboxylic acid. But in the case of a secondary alcohol, there is no free bond, so that we can't oxidize it any further than a ketone. Okay, so a tertiary alcohol, trying to oxidize a tertiary alcohol. Now, if you notice, you've got a carbon-carbon bond, carbon-carbon, and a carbon-carbon. So you've got 3 carbon-carbon bonds, which, as I said before, are really hard to break. So you can't actually oxidize a tertiary alcohol any further. So it doesn't actually react with any oxidizing agent that you have with it. Okay, so the first one here, if you look at this carbon, it's joined to 2 other carbons, so it is a secondary. When you react it, acidified dichromate with heat, or acidified permanganate also with heat. And then we're going to oxidize this carbon here, so we lose this H and this H, so we end up with the double bonded O in the middle, so we get a ketone. Remembering that carbons can only have 1, 2, 3, 4 bonds. Next example, with our oxidizing agents, same as before. If you look at it, this is our carbon here. It's joined to 1, 2, 3 other carbons. So this is a tertiary, so it will not react. The final one is the two-step. So we'll react it with our oxidizing agent, same as in the first reaction. We'll get see, I forgot the H's there. So that is our first reaction. And when it continues to react, we end up with the carboxylic acid.